All right, folks, let's go through these final exam review problems. Now, if you'll look at this first problem, notice what's in between these sets of parentheses. You've got subtraction and addition. So this is just adding polynomials or subtracting polynomials. What's the key here? Like terms. So what I want to do before I add any or combine any like terms is distribute this negative sign in the parentheses. Okay, so that's got to go inside. It's going to change both of these signs. These other parentheses with the plus in the front, and this is an implied plus here, those signs don't change. So if you would like to rewrite it, 5a to the third minus 7a squared b minus 9ab squared plus 4b to the third, that would be the most missed thing I see on a problem like this, plus 3a squared b plus 4ab squared. So negative out front changes the signs. Then you combine like terms. I combine a 5a to the third with any other a to the thirds that I have, and I don't have another one. So I'm going to bring that down, 5a to the third. A squared b, I'm looking for other a squared b's, and I do have them. This is a negative 7 and a positive 3. When I combine a negative 7 and a positive 3, I get negative 4a squared b. Now the next term is an ab squared. I combine that with another ab squared. So I've got this one that I'm combining with the last one. Take the sign with it. Negative 9 and a positive 4 is negative 5ab squared. And then finally I'm only left with 4b to the third. I don't have a like term for that, so it's just 4b to the third. This is your final answer. There's nothing else you could do with this except rearrange terms. And there's certainly no need to rearrange these terms, so that's your final answer. Notice the next problem, though, is multiply. All right, so you're dealing with a different situation. When you multiply, this is binomials, two terms, binomial times a binomial. Y'all know the FOIL method. 6x times x is 6x squared. Then I multiply 6x times negative 5. That's negative 30x. 2 times x is plus 2x. And then 2 times negative 5 is negative 10. Be sure to combine like terms before you wrap that one up. So if I come to the right, that's 6x squared. Negative 30x plus 2x is negative 28x minus 10. You don't do anything else with that. This is not equal to anything. You're not solving anything. You're just simply multiplying these two binomials together. All right? You got to know your properties or your laws of exponents. Okay, so one of the rules is when you have a power to a power, like we have in the numerator, you multiply exponents. So that's x to the 20th divided by x to the 5th. Then you have a rule that when you divide the same base, you subtract exponents. So that's x to the 20 minus 5, which we know is x to the 15th power. Moving on to problem 4, got a slightly more complicated problem where you're dealing with laws of exponents. But notice this, the negative 48 and the 14, those are just coefficients. You reduce those fractions to lowest terms like you would any regular fraction, okay? So I'm going to handle that first and get it over with. What number divides into both 14 and 48? And we know that number is 2. So 48 divided by 2 is going to be 24. Now that negative is up there. You could say negative 24. 14 divided by 2 is 7. Fraction is reduced to lowest terms. Now, next what I want you to do is focus on the x values. X to the 9th and x to the 12th. You're dividing, so you subtract. But if I subtract the top minus the bottom, 9 minus 12 gives me a negative exponent. But I'm supposed to write all these answers with a positive exponent, so subtract the other way. 12 minus 9, you leave the answer where the bigger number is. X to the third goes in the denominator. Okay. Now, finally, let's take a look at our y values. Now, if you want, we know that negative y values just move to the other side of the fraction bar. So I can move that y to the 4th to the bottom. And now it's not up here anymore. You could do that, and then when you multiply bases, you add those exponents, so that would give you a y to the 7th. Another way to handle that is just like we did the x's. The bigger of these two exponents, which is 3, is on the bottom, so 3 minus a negative 4. Now careful there, notice I'm saying that's y to the 3 minus a negative 4 also gives us y to the 7th. And it's in the denominator because the bigger exponent is in the denominator. And that is completely simplified. Problem number 5. We have a square on the outside. Don't make the mistake that many students make and you square each part. That is not what's happening. You have to FOIL this out. You're not just squaring the 4x to the 3rd and the 3. You need to write it out twice. 4x to the 3rd times 4x to the 3rd is 64. And remember what you do with those exponents. When you multiply bases, you add exponents. So that's going to be the 6th, not the 9th. 4x to the 3rd times negative 3 is negative 12x to the 3rd. Negative 3 times 4x to the 3rd is another negative 12x to the 3rd. And then finally, negative 3 times negative 3 is a positive 9. Once again, we have like terms right there in the middle. So 64x to the 6th does not have a like term across here, so I just bring it down. Negative 12 added to a negative 12 is negative 24. Again, big mistake that students make is when they add like terms, they change the exponent. You keep that like term. That stays x to the 3rd and then plus 9. And that is your final result there. Now let's move on to factoring. This number 6 problem is one of the more challenging factoring problems, I think. Notice we've got a trinomial and we have a leading coefficient of 3. If you would like to try trial and error, you would just go ahead and put your 2 sets of parentheses down and play around with the numbers that would go in there. Now we know to get 3x squared, the only way we can do that is with a 3x and an x. And we know to get a 5 or a negative 5, the only thing that multiplies to give you that is a 5 and a 1. The question is, where do you put the 5? Where do you put the 1? Not only that, one of them is negative and one of them is positive to get that. Now, I'm going to put the plus 5 over here. Why? Because I have 3x times 5. When I FOIL this, that's going to give me 15x. And see, the minus 1 would go there. Now, y'all, I've been teaching for a really long time, and it's taken me a while to get proficient at doing this by trial and error, and it's still not my preferred way to do it. So how do you do it otherwise? Well, you remember the AC method, where you multiply these two numbers together. I'm finding numbers that multiply to be negative 15 and add to be 14. Now, what two numbers do that? Well, we know it's a positive 15 and a negative 1. That's our two numbers. Now, when you come up with your two numbers, remember what we typically did was we would say, you know, x plus 15, x minus 1, but you can't do that when you have a leading coefficient of 3. So what you're doing is you're rewriting the middle term. I'm replacing that circled 14x with 15x minus 1x and then minus 5. If I combine my like terms back together to get 14x, it would give me that, right? Then you do factor by grouping. In other words, you group these two together and these two together. You factor out the greatest common factor of that first two set. Notice they both have a 3 factor in common and an x. So you pull out the 3x, and that leaves you with x plus 5. On this side, they both have a negative 1 in common, and that's it. I pull out a negative 1. That also leaves me with x plus 5. Remember, the trick with factor by grouping is those parentheses must match. So I'm going to factor out that common x plus 5, and then times what's left in front, which is 3x minus 1. Now again, it took me a little bit longer, right? But this problem was easy to do using the trial and error method. They are not all easy to do, but you know what is easy to do? This AC method every single time. So anytime you have a coefficient that's not a 1 right there, try this method that I've got over here. Okay? It works every single time, and not only that, you get extra practice factor by grouping. All right, now this is what we call a difference of squares, number 7. And a difference of squares factors into one positive binomial and a negative binomial. More than that, right? You take the square root of 9y squared, that goes in the first position. And the square root of 64, which is 8, goes in the second position. You make sure that these don't factor further and you are finished with that one. Now this problem right here looks odd. Why? Well, it's got a leading coefficient of 1. So that means that all this, what I've got circled over here in pink, you don't have to do all that. But it's got this extra y squared and an xy term in the middle. You know what that does? That adds the y to the numbers that you find. So you're looking for numbers that multiply to be negative 18 and also add to be negative 17. What two numbers do that? Well, how about a negative 18 and a positive 1? What do you do with those numbers? Remember your two sets of parentheses. And you say x minus 18, x plus 1, using my two numbers. But look, it's got that extra y squared and xy here. That means y's go with those two numbers. And that's it, y'all. Okay? More factoring. And I know you realize this from the factoring test, but the issue with factoring is not really as much how you do each method. It's recognizing what method you're supposed to use. I know you know this. Well, look, we got a trinomial. Oh, I did that one already, right? We did 8. So let's don't do that one. Okay? Okay, we did it. Okay, now back here, factor by grouping. It told you to do factor by grouping, but even if I didn't tell you to, it's got 4 terms. So you attempt to group the first 2 together and the last 2 together and factor out a greatest common factor from each. What do the first 2 have in common? B. What does that leave? A plus 4. Okay, what do the second 2 have in common? 5. And it's a positive 5. You have to put that plus there. And that also leaves A plus 4. Now look, these match, which means I can factor that out front. That's A plus 4. What does that leave? B plus 5 in parentheses. Now, if you ever feel that you need to rearrange these terms so factor by grouping will work, you're totally allowed to do that. I typically don't rearrange the terms. I try it as is, and then if for some reason, which is rare, but for some reason it doesn't work, see if you could possibly rearrange them and get them to work for you. All right, how about problem number 10? So another factor problem. Now, the first thing you should always do when you factor, and I haven't been doing this because I'm flying through these problems, but we should always look for a greatest common factor. The problems that we did, let me back up just a little bit. No, that's multiplying. Here's factoring. None of these 3 had a greatest common factor. So I still glance at it, but I forget to say out loud, hey, I'm looking for a greatest common factor, but you should. These 3 terms don't have anything in common. These 2 terms don't have anything in common that we can divide out, neither do these 3. But when I go back to this problem number 10, 48 and 12 can both be divided by 12, and x to the 5th and x to the 3rd, we can pull out an x to the 3rd. So do that first. 12x to the 3rd comes out. All right. If I take this and divide it by 12x to the 3rd, I still have 4x squared left. If I take 12x to the 3rd and divide it by 12x to the 3rd, I have a minus 1. I'm not done with this problem. You know what? That's a difference of squares. What do I mean by that? Remember, that's when you have the situation that you have a minus and you have a perfect square and a perfect square. So I need 1 plus and 1 minus here. I take the square root of the first term is 2x. That goes in the first position. And the square root of the second term after the minus sign, the square root of 1 is 1. And that goes in the second position. And now this problem is completely factored. So yes, the first line is factored, but it's not factored completely. And even if the problem doesn't say factor completely, you should always factor completely. Number 11 is a basic trinomial. Notice the leading coefficient is 1. I'm trying to find numbers that multiply to be positive 2 and add to be negative 3. Are there numbers that do that? Well, think about multiples. Don't think about things that add to be negative 3. Think about multiples of 2. The only thing that multiplies to give you 2 is 1 and 2. But they can both be negative, which would add to negative 3. So a negative 1 and a negative 2 would work. What do? You just draw your 2 sets of parentheses. Now, careful, there are y's in this equation. So it's going to be y minus 1 times y minus 2. Does it matter if you put the 2 here and the 1 here? Absolutely not. As long as you have the correct sign in front of that term in your factor, then you will get it correct. All right, number 12. I'm supposed to simplify the expression. Remember, we've done something like this already in this review. So I'm going to have a fraction as an answer, likely anyway. I need to first look at just my numerical fraction right here. What do those two numbers have in common? What can we divide both of them by? And I hope you see that it's 9. So I'm going to divide negative 81 by 9, and that's going to give me negative 9. I'm going to divide 18 by 9, and that gives me 2. Now I'm going to move on to the x. Look, all right, you know the rule, you subtract. You subtract bigger number minus smaller and leave it where the bigger value is. 7 is bigger than 2. 7 minus 5 is 2. That's going to give me an x squared in the denominator. Look at my y values right here. Y to the 6 is bigger than y to the first. That's a first right there, right? Or a 1. So I do top minus bottom. 6 minus 1 is 5, but that y to the 5th goes in the numerator. Now this negative right here, it can either go out front or it can stay in the numerator with the x squared. Both of these answers are correct. Okay, we have another simplify the expression. But now I can't just cancel x squared, xx. We can't do any of that, right? This is not factor. This is addition and subtraction of terms, and so is this one. So you know what we have to do? We must factor first. Now remember the problems we did earlier? It's like, well, didn't you just cancel earlier? Look at this one. Hey, that's all multiplication. You can cancel all day long right there. You know, x to the 5th and x to the 7th. 5 of those 7ths cancel with those 5s right there. But when it's addition and subtraction, you must factor first. We have to write this as a product. Oh boy, so there's work to be done here. Notice all the space that I've given myself to do this problem. So I need to factor 15. Oh, I need my pen back too. Stand by. All right, I need to factor 15x squared plus x plus 2. What's the problem? The 15. Remember the trick? You multiply those two together. I'm looking for numbers that multiply to be negative 30. And add to be 1. Where'd the 1 come from? That guy right there, 1x. What numbers will do that? A positive 6 and a negative 5. Oh, wait, it's supposed to add to be positive 1. That is add to be positive 1, right? And does multiply to be negative 30. So what am I going to do with that? I'm going to rewrite 15x squared as plus 6x minus 5x minus 2. Remember, you have to do that, or you have to do trial and error. Biggest thing that comes out of here when I do factor by grouping is 3x. That leaves 5x plus 2. Biggest thing that comes out of here is a negative 1. That also leaves 5x plus 2, which means my final factor numerator is 5x plus 2, the one that matches, times 3x minus 1, the guys out front. So I'm going to write that over here, 5x plus 2 times 3x minus 1. Now I'm going to do a similar process in the denominator. So I need to multiply the first and the last number together. So I'm looking for numbers that multiply to be negative 6 when I multiply those together, and also add to be the middle guy, 5. What numbers do that? Okay, things that multiply to be negative 6 are 2 and 3, positive and negative, but those don't add to be a positive 5 because you have to have one positive and one negative. Be careful with this one. So how about a positive 6 and a negative 1? Those do multiply to be a negative 6, and they do add to be a positive 5. Okay, I can see a lot of people missing that one. 3x squared plus 6x minus 1x minus 2. Again, I'm replacing the 5x with those two numbers we came from with the variable with it, right? That's an x. Now, factor by grouping. What comes out of here? 3x comes out, common to both. X plus 2 stays inside. Right here, a negative 1 is the only thing common, but it does leave an x plus 2, which is what we require. And now factored is the guy that matches x plus 2 times those GCFs out front. So when I write that over here, I have x plus 2 times 3x minus 1. Now, because this is a product, I can cancel that entire 3x minus 1 with that one. And my final result is 5x plus 2 over x plus 2. Now, I bet you can cancel those 2's, can't you? No, no, no. You can't cancel addition, subtraction. You can only cancel factors. Those are things multiplied together. All right, next problem. It's a big one. You know what this involves? A lot of factoring. A whole lot. So let's get to it. Not only that, all of these have a coefficient. So this problem is going to take me longer than any problem we do in this review, I bet. So because I have a coefficient, I got to do that little trick where I multiply those together. I'm looking for numbers that multiply to be negative 12 and add to be negative 1. That negative 1 right in the middle. What's going to do that? Negative 4, positive 3. Then I take my original problem, which I'm having a hard time writing because I want to write x's and not k's. 6k squared minus 4k, can't even write a k, plus 3k minus 2. Factor by grouping. Probably tired of doing this already. 2k, that's 3k minus 2. Over here, nothing in common here. I'm just going to pull out a 1. That leaves me 3k minus 2, which means this factors into 3k minus 2 comes 2k plus 1. You may want to go ahead and move it over here. I'm going to do this in green, and I'm replacing that with what we just found. So it's k minus 2 times 2k plus 1. Now I'm going to move right down to the denominator right here and factor that guy. Sorry for the text message. I'm waiting on a phone call too, so if it rings, I'm not even going to edit the video, y'all. I'm just going to pause it, answer the phone. I'm waiting to make a doctor's appointment. So here we go. So I'm trying to find numbers that multiply to be 24 and add to be 10. What numbers do that? Multiply to be 24 and add to be 10. Don't take too long, 6 and 4, right? Okay. Now, then I just factor in a k plus 6, k plus 4. No, goodness, no. We still got to do all this. 8k squared plus 6k plus 4k. That's why I did this, to do my numbers that I'm going to replace for the 10k plus 3. Then I factor by grouping. What comes out of here? Well, there's a 2 and a k, and that leaves 4k plus 3. The second set here, nothing factors out of there. So what does that mean? Well, it's a 1, right? If they have no greatest common factor, you're really just factoring out a 1. But look, what's important is the parentheses match. 4k plus 3, the matchy guy, times what's out front, 2k plus 1. And that goes underneath. 4k plus 3 times 2k plus 1. Moving on to this next set here. Let's pick another color. How about purple? Okay, so 4k squared plus 7k plus 3. I multiply the first and the last. I'm looking for numbers that multiply to be 12 and add to be 7. Hey, 4 and 3, right? So that's 4k squared. I'm replacing the 7k with 4k plus 3k plus 3. You do this problem and you've got this method down, I promise. So 4k comes out. That leaves k plus 1. Here, a 3 comes out, that leaves k plus 1. And then the matchy guy, k plus 1, times the numbers out front, 4k plus 3. If it's going too fast, just slow the video down. So k plus 1 times 4k plus 3. How's that? I'm not trying to be a smart aleck, I'm sorry. Okay, now, this last one down here, 3k squared plus 5k plus 2. It is quite the process, isn't it? Let's pick some other fancy color. Aqua blue. Alright, so multiply these two together. Multiplies to be 6, adds to be 5, right? So multiplies to be 6, adds to be 5. What numbers do that? 2 and 3, yes, of course. Okay, so you got 3k squared plus 2k plus 3k plus 2. Group those guys together, 2 at a time. What comes out of 3k squared plus 2k? The only thing they have in common is the k. So that's going to leave 3k plus 2. Okay? Over here, they don't have anything in common either. I'm just going to put out a 1. That leaves 3k plus 2. Now, what matches? 3k plus 2 times what's out front, k plus 1. And I'm going to move it right up here into my big problem. 3k plus 2 times k plus 1. That's where all the work came in. Am I right? Now, because this thing is factored, I get to cancel all over the place. Anything that's in the numerator, any factor that's in both the numerator and denominator can go. 2k plus 1 cancels with 2k plus 1. 4k plus 3 cancels with 4k plus 3. K plus 1 cancels with k plus 1, which means I'm left with a k minus 2 over 3k plus 2. Final answer. A whole lot of work.